Hello students, welcome to JCE Connect series of lectures. In previous session, we have derived a Bernoulli's equation, that is Bernoulli's equation of motion for the fluid. The equation we have derived here as this one, that is P plus half rho V square plus rho into G into y is equal to constant. So what does it mean? So in a fluid under a streamline flow, the total energy at every point remains constant. So the total energy consists of pressure energy, kinetic energy and gravitational potential energy. The sum of these three energies is constant for a streamline flow. So this is the equation which is given by Bernoulli, that is a Swiss physicist. Okay, and based on this principle, a number of devices operate by means of the pressure differential that results from differences in fluid's speed. So means many machineries or many devices which will work on this principle. So we'll see it later, the application part of the Bernoulli. So here in this particular session we'll discuss about the applications of Bernoulli's equation. As we know, the Bernoulli's principle which states that for an streamline flow, or if the fluid is ideal or incompressible fluid, the total energy at every point remains constant, or in other words, this principle states that as the velocity of fluid increases, the pressure exerted by the fluid decreases. Okay, so means this principle says that the pressure or the velocity is inversely proportional. I can write like this: the pressure is inversely proportional to the velocity. So this is the principle of Bernoulli, and let us see how this equation works on practically on various devices which operates. Okay, so let us study about the first application here. So we all know this is the equation which the Bernoulli has got after after using the energy principle. So this equation is being derived based on the law of conservation of mass. This equation consists of three forms of energy. Means whenever a fluid starts flowing, it will be having three forms of energy. So they are the pressure energy, kinetic energy and gravitational potential energy. So under the streamline flow, wherever you take the section, at that particular section the sum of all three energies will be constant. Either it could be a section 1, it could be a section 2, 3 or 4. So wherever, so for a streamline flow the total energy will be remains same. So that is the concept of Bernoulli's principle. But so what exactly this equation tells? So one form of energy at a particular section, one form of energy get decreases and other form of energy get increases. But when you take the sum together, that will be remains constant. That is the law of conservation of mass. Means in expenditure of one energy, the other energy get adding, and at last the sum, that is the total energy, remains constant at that particular section. So that is the Bernoulli's equation. So we'll see, or we'll discuss some of the practical application of this particular equation, how it works, and how one form of energy get increases and other form of energy get decreases, and finally how we get the total energy remains constant. So let us take the first application. So before that, you all just try to understand here. Stone is falling from a particular height down. So when the stone is at a higher elevation, so if the stone is here, so when the stone is here, the potential energy will be high. Just look here. When the stone is here, just a minute, when you keep a stone at higher elevation, it means the potential energy will be high. At the same time, the kinetic energy will be zero. So as the stone falls down and down, so at this particular point, the kinetic energy at this particular point will be increasing and the potential energy get decreases. So when the stone is here, the potential energy will be high. When the stone comes down, or it falls down, the kinetic energy get increases, potential energy get decreases. But when you take the sum together, potential energy plus kinetic energy equal to total energy will be remains same. So on like that, here also in this particular Bernoulli's equation, when we take the sum of three forms of energy, the pressure energy that we get because of the pressure what we apply for the fluid to take the motion, and the kinetic energy because of the motion it gains the kinetic energy, and potential energy because of the position, whatever the energy it gains, that is called as a potential energy, and the sum of all three forms of energy will be constant. So okay, so I hope this is clear to you. So this example I have taken to make you understand the Bernoulli equation. Okay, so let us consider what the Bernoulli's principle states. The Bernoulli principle states that as the speed of moving fluid increases, the pressure within the fluid decreases. So fluid can be in a liquid or a gaseous state. Okay, the animation shows the lift produced. So here we are taking the aeroplane, that is the lift produced as a result of the low pressure created on the upper surface of the aeroplane wings compared to the pressure on the wings lower surfaces, causing the wing to be lifted upward. This uplifting is mainly on the basis of Bernoulli's principle. So here this animated picture, whatever I am showing here, so this is the aeroplane, so which is moving in the air. Okay, so there will be a air resistance. See, all the air particles are coming in this direction, they are hitting the aeroplane wing. So the lifting of aeroplane, so it depends mainly, or it works on the principle of Bernoulli, and the wings of the aeroplanes are being shaped in a particular shape, or they are designed in a particular shape. So like this, the upper surface will be little dome, little like this, means it will be like this, it will be at higher position. So like this, the upper part of the wing. So why these are being, or the wings are being made like this, like a dome shape. Okay, so the bottom surface is a flat one, so it will be generally like this. This will be like this. So the upper will be like this. So this is the shape of aeroplane wing. Why they are made like this? The shape of aeroplane wing. Okay, so it will be made like this. Okay, why it is made like that? Okay, so look at this one. So the air particles, the aeroplane is moving in this direction, it is going in this direction, and the air is moving in this direction, opposite to the motion of airplane. Okay, so what happens the moment the air particles will come and hit at this point here? So the air particles will get split up, so they all will be moving like a streamline flow. See, this air flow will be in the form of a streamlines. Some air particles will be moving in upward direction, and some will be moving at the lower part of the wing. Okay, so some air particle moving, or they take the path of upper portion of the wing, and some will take the path of lower portion of the wing. Okay, so what exactly will happen in this particular situation? So here what will happen here, the lift on an aircraft wing, which can be explained in part by the Bernoulli effect. Aeroplane wings are designed, as I said, they are designed so that the air speed above the wing, is greater than that below the wing. So this wing is been designed in a particular shape because the speed of the air particle should be more on the upper surface of the wing than the lower surface. So always the speed, whenever the air particle will come and hit the wing, the upper surface of the air should move faster than the lower surface of the wing. Okay, so as speed above the wing is greater than that below the wing. So as a result, the air pressure above the wing is less than the pressure below, and the net upward force on the wing called the lift. Okay, so what exactly will happen here? Just look at this picture here. The air particle will be coming like this, and they are hitting. So this is the moment of the air particle. You all can see here, aeroplane is moving in this direction. So it is moving in this direction, aeroplane. Just a minute. Okay, see, the aeroplane is moving in this direction, and the air is moving in this direction. So the air particles, that is a group of air particles, are moving, and they are in streamline flow. So they all are in a streamline flow. The moment they come and hit the edge of the wing, then all the air particle will get split up. Some of the air particles will take the upper surface of the wing and they move again forward, and some of the air particles will move on the lower surface of the wing and they move forward. Okay, but if you look at the wing, so upper surface will be having the longer path, and the lower surface will be having the shorter path. So what will happen here? The upper surface of the wing, on the upper surface of the wing, the air particle will move faster. The air will be moving very fast. So means the velocity of the air particle will be very, very high. So lower surface of the wing, the air particles will be moving slow. So they are moving very slow. Hence the velocity is low here. But what the Bernoulli's principle says, the pressure is inversely proportional to the velocity. Means wherever the pressure is high, there the velocity is less. Or you can write velocity is inversely proportional to the pressure. So both are same. Okay. So on the upper surface of the wing, the speed of the air is very high, hence the pressure is low here. On the lower surface, the speed of the air is low, hence the pressure is high. Hence a lift can takes place. The lift of the aeroplane can takes place. That's why, so to maintain the speed of the air on the upper surface of the wing, this the wing of the aeroplane is made in a particular shape, just to have a or you can produce the more speed of the air particle on the upper surface, just to maintain the low pressure on the surface. So that is here, look at this one, the upper streamline, and this is the lower streamline. The red line indicates the lower streamline, and this blue color indicates the upper streamline. The moment they come and hit the edge of the wing, so what will happen? So on the upper surface, so this will be the longer path. See that it is written here, longer distance, and the bottom one is the shorter distance. So on the longer path, the air particle will be moving very fast. They will be moving very fast, and the speed of the air particle will be very high. Hence, this is the reason of low pressure. On the lower side of the wing, the speed of the air particle will be very slow. Hence, the velocity of the air particle is less here, or you can say it is the velocity of the air particle will be slow. Hence, this is the reason of high pressure. Then there will be a difference in the pressure on the upper and the lower side. Hence, the lift of the aeroplane will be takes place. So here it is written longer path or the equal transit theory. This is called as the longer path or equal transit theory. Means here on the air particles on the upper side and the lower side, the time period to reach at this end will be given the same time period. If you given the same time period, since this path is longer one, this path is longer one, and this path is shorter one, and it is a straight. So what will happen? So to reach this point, this side particle will be moving very fast, because since it's a longer path and this is a shorter path, this particle will be moving very slowly and reach this particular point in a stipulated time. But this particular will again move very fast, and again they also reaching at the same time. Since on the upper side of the wing, the velocity of the air particle will be taking high, hence the pressure will be low here. On the lower side, the velocity of the air particle will be low, hence it is the reason of high pressure. It is written here, top of aerofoil is shaped to provide a longer path. So here this one, top of aerofoil is shaped to provide a longer path than the bottom. Air molecules have farther to go over the top, and air molecules must move faster over the top to meet molecules at the trailing edge that have gone underneath. So from Bernoulli's principle or from Bernoulli's equation, higher velocity produces lower pressure on the top. So the difference in pressure produces the lift of an aeroplane. So this is one of the application of Bernoulli principle. So here, so what we can observe here is the pressure is inversely proportional to the velocity. As the velocity increases, the pressure decreases. As the pressure increases, the velocity decreases. Wherever the velocity is high, the pressure is low. Wherever the velocity is low, the pressure will be high. Hence, the lift of an aeroplane will be takes place. So this is the concept, or you can say it is the one of the practical application of Bernoulli principle. So likewise, we can have n number of applications. So this is one of the application of Bernoulli principle. Okay. Let us discuss one more application. One more practical application of Bernoulli's equation, that is atomizer or a paint sprayer. Atomizer is an instrument used to spring performance to spring perfumes and water, that is called as a atomizer. So how these devices will work based on the principle of Bernoulli. So as you all know, that is the pressure is inversely proportional to the velocity. Whenever the pressure difference creates between the 2 points, either at one point the pressure get decreases and at that particular point the velocity get increases, or wherever the pressure get increases the velocity get decreases. Whenever this happens, that is the difference of pressure get happens, automatically the liquid may come up. Okay, so here also in these kind of devices, how the liquid comes out or it comes up. Okay, so just look at this type of a device, that is it is called as a atomizer, or you can call it as paint sprayer or a perfume sprayer. So in this particular devices, or these particular devices will work based on the principle of Bernoulli. So when the rubber bulb which is attached to this tube, here a rubber bulb is attached, when it is squeezed, the air flows. When it is squeezed like this, see by the finger, when it is squeezed, the air flows through the tube. In this particular, the air flows and comes out of the narrow aperture. See here, the air is moving and comes out with the narrow aperture here, that is a narrow aperture of the tube. As the aperture is narrow, as this opening is narrow, the velocity of the air increases in this particular tube as it comes out, and this reduces the pressure in the vicinity of the aperture, because the velocity of the air particle will be very high here. Means as you keep on squeezing this rubber bulb, see here this one you are squeezing rubber bulb, as you keep on squeeze this rubber bulb, here the means you are blowing the air in this particular tube, you are blowing the air in this particular tube. So because of the air you are blowing in this tube, the air particle will be having high velocity here. And because of this, what happens, because as I said, the pressure is inversely proportional to the velocity. As the velocity increases, the pressure decreases. So in this vicinity the pressure will be decreasing. But at the same time, when you take at the surface of the liquid, so here the velocity is 0 here. There is no velocity because this is completely stagnant liquid. So since there is no movement of liquid here, hence there is no velocity at all. So wherever the velocity is low, the pressure will be high. So because of this two different points, there is a difference in pressure. So here the velocity is high, the pressure is low. Here the velocity is low, the pressure is high. Hence there is a difference in the pressure. Hence, so it will be increases in this tube. Means the liquid rises in this tube. That is the direction of liquid in this tube. So as it comes up through this tube, here already the air particles are moving in this tube, they will be having certain velocity. So along with that, this liquid also get mixed up and it comes out with the fine spray. It will be coming out of the tube like a fine spray. So here it is written, the difference in pressure between the top and bottom of the tube draws the perfume upward. Hence you will be getting a fine spray out of the tube, and hence we can say this will be this particular device is working on the principle of Bernoulli, because there is a pressure difference between the 2 points. Hence here it is written, a small tube goes down into the liquid in the container, then what will happen here? A fast moving air moves over the top of the small tube. As I said here, I'll show here once again. Here a fast moving air moves over the top of the small tube. Here as you are squeezing, the air particles are moving very fast here. So okay, then there is a mobility of air particles. They will be having a speed, they are having a high speed, or they will be moving very fast. So according to the Bernoulli's principle, so what will happen? This results in a lower pressure at the top of the tube, because it will be having a very high velocity. Hence, wherever the velocity is high, the pressure is low. That is the principle of Bernoulli. So since in this particular vicinity there is a high speed air molecules, hence the pressure is low. So then so the higher pressure at the bottom of the tube, here there is a higher pressure at the bottom of the tube, will push the liquid or the fluid up the tube. Hence you will be getting a fine spray at the top. Okay, this is the one more practical application of Bernoulli principle. So written, a stream of air passing over one end of an open tube, the other end of which is immersed in a liquid, reduces the pressure above the tube. This reduction in pressure causes the liquid to rise into the air stream. The liquid is then dispersed into a fine spray of droplets. This is so called atomizer, is used in perfume bottles and paint sprayers. So means, as I said, atomizer is an instrument which is used to spray a perfumes or a paint or a water. Okay, so this device which works on the principle of Bernoulli. What is the principle of Bernoulli? The pressure is inversely proportional to the velocity. Wherever the velocity is high, the pressure is low. Wherever the velocity is low, the pressure is high. Hence there is a difference in the pressure. Hence whenever a difference in the pressure created, the liquid rises up in the tube. So that is the principle of Bernoulli. Even the centrifugal pump also works based on the principle of Bernoulli. So suppose this is a pump and you have connected a pipe. So if you want to lift the water from lower elevation to higher elevation, if this is the pump, say this is the pipe you have connected, and this is the tank. So if you want to lift liquid from this level to this level, if you want to lift, this is the pump running here. What will happen here? The shaft will be running. It is the shaft, the blades are attached to the the runner is attached to the shaft. Over the runner the blades are placed. As it starts rotating, here the high velocity of the blade will takes place. The runner will be having a high velocity, hence the pressure decreases at this region. Hence here the pressure, there is no pressure, the velocity is zero here, hence the pressure is increases here. So here the pressure is low, here the pressure is high, hence the liquid rises here, means the water rises, hence it reaches to the higher elevation. So here also we can say, based on the principle of Bernoulli, the water may get lifted up. So we can easily apply the equation of Bernoulli for the analysis purpose. Okay. So this is one more practical application of Bernoulli equation. One more application of Bernoulli's equation. as we know the principle of Bernoulli, the velocity of the fluid increases, the pressure exerted by that fluid decreases. Means the pressure and the velocity are inversely proportional. The pressure and velocity are inversely proportional. That is, pressure is inversely proportional to the velocity. This is the principle of Bernoulli. Okay. So to understand this particular principle, so here we have taken one practical example as the motion of a ping pong ball over a stream of water. Just look at this picture, animated picture, what I am showing here. So this particular picture. So here a stream of liquid which is coming out of the nozzle through this nozzle which is coming out, and as we keep a ping pong ball over a stream of water, or you can take it as a stream of air, so that ball will not be falling down. So what will happen exactly in this particular region? Okay, so this can be explained very well by Bernoulli principle, why this ball is not falling down. So let us place a ping pong ball in an upward stream of water. So when you place the ping pong ball over a stream of water or a stream of air, so here we can observe that when a continuous stream of water coming out of the nozzle, the ball rises to a certain height above the nozzle and stays at that height against the gravity, and also starts spinning. And we also observe that in case the ball moves to one side, means during spinning, if it moves on one side, automatically it will be brought back to the original position. So how does it happens? Means sometimes this whatever the ball is spinning here, sometimes it may come in this direction, sometimes it may come in this direction also, but whenever it comes towards the left, then on the right side of the stream particle, or the particle of the liquid will be moving very fast, and whenever the liquid particles will be having very high velocity, the pressure here will be less. So as the pressure is less, automatically the pressure on the other side will be more, so it will be pushing to its original position back. Okay, so here look at this one also, and this one also. Just look at here, a hair dryer, over a hair dryer a ping pong ball is placed here and here also, this picture. So but this ball is not falling down, so it is staying there itself. So it has raised a particular height and it is moving left and right all around, but it is not falling down at all. So the reason, whenever it moves on one side, the other side velocity of the air or the water will be more, then on the other side the pressure is more, so it is automatically taking back. So here what will happen, so this means this Bernoulli principle also explains the ping pong ball ping pong ball on the hair dryer, the stream of air causes, see, the stream of air causes the ball to rise. So whatever the stream of air is coming out of this hair dryer, okay, the stream of air is coming out of the hair dryer. So the stream of air causes the ball to rise. That the pressure in the air stream is lower than the surrounding air. So whatever the pressure in the air stream is coming out, it is lower than the surrounding air. If the ball moves out of the stream, if it goes here and there, it encounters high pressure, and that forces the ball back into the low pressure air stream. So that's why I told the pressure is inversely proportional to the velocity. See, look at this picture here. So it is written, the pressure pushes the ball back into the air stream. Means, suppose, as I said, so in this particular picture, as the ball moves towards a left, say in this case, suppose if it is moving towards the right, here it is, this is the right. What will happen if suppose it comes towards the right, suddenly the air particle will be taking in this direction like this, they will be moving on this side, but it will create a longer path to move the air particle for the water particle. Hence obviously they will be having a very high velocity. Okay, so as I said, wherever the velocity high, the pressure, this is the region of low pressure. So in this particular region, there is no velocity of the liquid. There is no velocity, means this is the region of high pressure. So what will happen? The pressure pushes the ball back into the air stream again. Suppose this ball comes this side. Suppose this ball comes this side. What will happen? The fast moving air has a high speed. Hence the low pressure will get created. Suppose if it is standing at the middle, means it is not means continuously it is standing at the middle, means so both the side the air has a very high speed. Wherever the air has a very high speed, there the pressure is low. There the pressure is low. Hence it is being kept at one point, that is at the center. So here a surrounding air has a low speed, high pressure will be creating. Hence automatically it is brought back to the original position. And according to the Bernoulli's theorem, the pressure of the fluid on the right is less. The pressure of the fluid on the right is, on the left is less. The pressure of the fluid on the right is in this particular case is the pressure on the right side of the ball is high. Hence it is being pushes back into the air stream. Okay, hence it will not fall down. So this difference in pressure on the left side as well as on the right side, so which will be returning the ball into its original position. So this is also one more application of Bernoulli's equation. So in these all pictures, just look here, a ball is placed over a stream of air particles, So here in this picture, in this picture and in this picture, the ball is not even falling down. The reason, wherever, in whichever side, suppose in this one, suppose the ball is moving in this direction. So if ball is coming in this direction, the air particle will be moving in this direction surrounding the ball. So air particle will be moving in this particle. So air particles moving in this direction means these air particles will be moving very fast. So wherever the air particles are moving very fast, there the pressure is low. it is a low pressure region. And in this one, compared to the air particles, the surrounding air, which is the atmospheric air, which will be having less velocity or the less speed, hence this region is high pressure region. Automatically it is pushing in this direction. That has been shown here. Okay, suppose it comes in this side, again it will be having a high pressure region, and this side it will be having a low pressure region. Automatically it is been brought back to its original position. So that's the same it has been given here. So the ping pong ball on the hair dryer, that is the stream of air causes the ball to rise, then the pressure in the air stream is lower than the surrounding air. If the ball moves out of the stream, it encounters high pressure, and that forces the ball back into the low pressure, that is air stream. Okay, low pressure air stream. So this is also one of the application of Bernoulli principle, that is ping pong ball. And one more application of Bernoulli principle. Suppose if you have tied two balloons like this, a distance apart. These are the two balloons are tied distance apart, and if you check in the middle, if you check in the middle of the balloon, the pressure here is normal pressure, and here also the normal pressure, that is the atmospheric pressure here. So initially you have tied the two balloons, and the pressure, if you check here, you will get the air pressure, that is atmospheric pressure, left side, in the middle, the right side. And suppose if you blow the air in between the balloon, see, if you blow the air, so air particle will be moving in this direction, which will be having a certain speed. So they will be having a speed. So wherever the speed of the air is high, there the pressure will be low. Okay, so whenever at the middle a region of low pressure get created, on the other side, this side, there is a atmospheric air present, compared to this region pressure is low, so this side it will be pushing. Okay, air will be pushing this side as well as from this side, hence these two balloons will come closer and closer. Okay, so just look at this picture here. So the two balloons are being tied here, and this person is blowing the air in between the two balloons. So here in this gap he is blowing the air. So as the air particles are moving here with a very fast, air particles are moving the high speed. So wherever the speed of the air particle is more or high, there the region of low pressure. On the other side, from this side and this side, there is atmospheric air which pushes the balloon, and these balloon will be coming closer and closer. So one more picture, just look here. Again the balloons are being tied here. Just he is passing the air in between the balloon, and wherever the pressure is low, means the high velocity of air is being passing. Wherever the velocity is high, the pressure is low. On this side and this side, the velocity is less but the pressure is more, hence these will be coming closer and closer. So this also you can say this is again tells or these will work based on the principle of Bernoulli. that is pressure is inversely proportional to the velocity. Just wherever the velocity is more, see here the air is been blowing in between, the velocity is more here, velocity of the air particle is more here, hence this is the region of low pressure. On this side there is no air particle movement, air is not at all moving here, hence this is the region of high pressure, hence this side air as well as this side will push the balloon, hence the balloon will come closer and closer. Just this is also one more application of Bernoulli. Okay. Yes. Again here also you can look here, you can say how it is possible. This person is applying air to that wrapper. Okay, how it is possible? It is possible because on one side he is creating a low pressure region and the other side he is creating a high pressure region, hence it is possible to keep that one in a position. Okay, so this is because or you can say it is the principle of Bernoulli's. So one side you need to create a high pressure and the other side you need to create a low pressure. One more side, see this person is blowing air over the piece of paper. So on this upper side, so he is blowing the air on the upper side, he is blowing the air, means he is making the air particles moving faster over the piece of paper. The air particles are moving very fast over the piece of paper. So means this upper surface is the region of low pressure and the lower surface there is no air particles are moving here, hence this is the region. This is the region of high pressure, hence it is been lifting up. See here, the same thing will happen in case of a aeroplane wings. On the lower side it will be creating a high pressure, hence on the lower side we can say it is a region of high pressure, upper side it is called as a region of low pressure. The pressure is low here, the velocity is more here. The pressure is high here, the velocity is low here. Okay, so this is also we can say this is this will happen because of the principle of Bernoulli, or you can say it works on the principle of Bernoulli. So these are some of the practical application of Bernoulli's equation. Only thing you have to remember, the pressure is inversely proportional to velocity, or in a streamlined flow the total energy remains constant. That is the principle of Bernoulli. Or in a streamlined flow, one type of energy get increases and other type of energy get decreases, but at the end the sum of the total energy will be remains constant. So that is the principle of Bernoulli. Okay, I hope you understood this practical application of Bernoulli. So likewise you can identify n number of applications in day-to-day life. Okay, thank you.